In this video, I will demonstrate how to create a smart hardware type component that uses Autodesk Fusion configurations together with JoinerCAD Smart Hardware features. For simplicity, we will use a basic component, a dowel pin. Its dimensions will be controlled using configurations, and for placement, we will use the template provided with the JoinerCAD installation. It is important to note that configuration-based hardware is created in a single file and then inserted into another file that controls the placement logic of the component. I will start by creating the dowel pin. Since this component will be controlled using configurations, the first step is to create the parameters that will drive those configurations. I open the parameters dialog and define values for the dowel's length and diameter. I also add two additional parameters, L1 and L2. These parameters define how the dowel length extends in each direction within the joint. They are not required for a functional component and are used here purely for learning and demonstration purposes. Next, I create the dowel geometry. It is important to understand that this file will contain not only the dowel itself, but also the geometry of the hole that will be used for cutting. I model the dowel so that its shape and proportions are as close as possible to a real-world component. Now, I create a new solid body that will be used to cut the holes in the panels. This geometry is created on the same XY plane and uses the same parameters as the dowel itself. However, I add an extra 5 mm so that the hole in one of the panels will be slightly deeper. Please note that when using the extrude command, I select the operation type New Body, which creates a separate solid body. For better visual clarity, I adjust the transparency of the bodies and apply a pine appearance. As mentioned earlier, I now set the sculpt type for each solid body. The dowel itself is set to neutral, so it will be ignored during the sculpt operation and will not be affected. The whole body is set to subtractive, meaning it will be used to cut material. I change the root component BOM type to quantitative so that the dowel is properly counted in the BOM. After that, I save the file. Next, I create the configurations that will allow the dowel dimensions to change. I open the display configuration table and define 4 different configurations. After clicking Add Parameters, I select the parameters from the parameter table that I want to control and assign appropriate values for each configuration. I also update the part number for each configuration. These values will later appear in the BOM. Once this is done, I save the file again. As you can see, all configurations are now available. When I switch between them, the dowel dimensions update automatically. And the part number changes accordingly. To control the number and placement of dowels, I use an existing template that is provided with our library files. I copy this template and rename it for my project. After opening the template file, I insert the dowel file into it. To keep the workspace clean and easy to understand, I hide unnecessary components and enable the sketch that defines the dowel insertion centers. Using the joint command, I attach the dowel to one of the sketch centers. I then use the pattern command to duplicate the dowels. I specify that the pattern operates on components. Set the distribution to spacing, and define both the quantity and distance using parameters already stored in the template. These values can be changed at any time through the Parameters dialog. I changed the root document BOM type to translucent. This ensures that the assembly itself is ignored in the BOM, and only the dowels inside it are listed with a quantitative status. I verify that all required parameters are correctly mapped and confirm that there are no errors. For testing, I am going to create a joint consisting of two panels. Please note that I select the hybrid environment, where all JoinerCAD tools are available. Starting from JoinerCAD version 3.2.0, we support the new Autodesk Fusion intent-driven design environments, where JoinerCAD commands are automatically enabled or disabled based on context. The hybrid environment allows all commands to be used, which makes it ideal for testing and demonstrations. Using the convert function, I convert the solid bodies into panels and save the file. Without this step, the created dowel cannot be inserted. Using the hardware attachment command, I attempt to insert the dowel. During insertion, a drop-down menu appears, allowing me to select the desired dowel configuration. After insertion, an error occurs. The dowel is placed incorrectly. This happens because I did not use the rigid group command when creating the hardware. I delete the dowel and return to the hardware file to create a rigid group. Rigid group is essential to ensure that all parts of the component remain in the correct position after placement. This is a very common mistake, which is why I wanted to demonstrate it here. I insert the dowel again. This time it is placed correctly. I perform the sculpt operation and confirm that the holes are cut correctly. Finally, I generate the BOM and verify that the quantities and part numbers are transferred correctly. The work is complete. We have created a configuration-driven dowel that cuts holes correctly and passes accurate data to the BOM.